Okay, here is my review question for physics. It combines three units: projectile motion, energy, and sound. It's pretty long, so I'm not going to read it all out right now, but it's basically about an archer who's trying to hit a target on the ground that is 150 meters below him, and he has to shoot over a wall. And you have to find out which part of the target he hits, or if he even hits it at all. And using that information, you have to find out if he in the end wins the competition or not. And there's also one question about sound here, which goes: how long after shooting the arrow does he hear the crowd's reaction if they react 0.3 seconds after the impact of the arrow? So it's mostly projectile motion, but it has a little bit of energy and sound in it as well. So the first thing that we always do with any projectile motion question is draw a diagram. So that's what I did here. So this is the diagram that I drew. As you can see, the castle wall here is 165 meters tall. The archer's elevation is 150 meters above the ground where the target is, and the center of the target is 60 meters away from the wall. He's shooting at an angle of 60 degrees from the ground, and his eye level is 1.7 meters. And then there are also the other measurements like 10 meter. The fact that he's standing 10 meters away from the wall, the fact that the target is 10 meters wide in total, and that the middle portion, which is the most valuable in terms of how many points it awards, is 4 meters wide in the center. So the first question here says basically, okay, so the question itself is, will the archer be executed? But as you can see in the question here, it says that he's going to be executed if he hits the wall. So it's basically just asking you if he hits the wall with his arrow or if he manages to clear it. So to work this out, the first thing that you have to do is calculate initial velocity. And although it never gives you initial velocity in the question itself, it gives you two important pieces of information that you can use to calculate the initial velocity. One is the amount of kinetic energy that the arrow had, 31 joules, and the other one is the mass of the arrow itself, which is 100 grams. Now you can use that information to get velocity because there's this formula from the energy unit: kinetic energy equals 1/2 multiplied by the mass multiplied by velocity squared. So if you just substitute all that information in, you should be able to work out for velocity. And according to my calculations, velocity is 24.90 meters per second. But then also, because it said that the archer shot the arrow at an angle of 60 degrees, you have to take that into account. So you have to find the horizontal, you have to divide up the initial velocity into its horizontal and vertical components. To find the horizontal component, you have to do 24.9 multiplied by the cosine of 60, and that gives you 12.45 meters per second. And to find the vertical component, you have to do 24.9 multiplied by the sine of 60, which gives you 21.56 meters per second. Now, if we take another look at the diagram, we can see that the archer is standing 10 meters away from the wall. And this is important because now we can use that information, we can substitute it into this equation here. So what we basically know is that the first thing that we have to find out is how long it takes the arrow to reach the horizontal displacement of the wall. So we have to find out how long it takes the arrow to travel 10 meters, essentially 10 meters horizontally. So we can use that 10 meters, we can substitute it in for horizontal displacement, and then we can use that horizontal component of the velocity that we just worked out and substitute that in for horizontal velocity. And then the formula that we use is time equals displacement divided by velocity. That is one of the most basic formulas in physics and in motion. So what we get when we substitute everything in is time equals 0.80 seconds. That basically means that that's how long it takes the arrow to go 10 meters horizontally. So we can use that information now to work out how high the arrow was after 0.8 seconds. So now we use this formula here. This is this is a formula from kinematics. It's vertical displacement, or any form of displacement actually. Displacement equals initial velocity multiplied by time plus 1/2 multiplied by acceleration multiplied by time squared. So if we're working out vertical displacement here, we have to make sure that vertical displacement has to be greater than the height of the wall for us to conclude that the arrow did clear the wall. If it's lower than the height of the wall, then that means that the arrow did not clear the wall. So that's what we're looking for here. So if we so we know 3 of these variables here, and we can work out for the 4th, which is vertical displacement. So we know initial velocity from the vertical component that we calculated at the beginning. We know time from this question, from this working out that we did right here, and we know acceleration because that's the force of gravity, and and then this is just time again. So if we substitute all of those values in here, we end up getting 14.11 meters. Now, if we look at the diagram, we can see that the wall is 165 meters tall, but also that the archer it has an elevation of 150 meters. So that means that the wall is actually 15 meters tall compared to the surface that he's standing on. So the arrow just has to clear 15 meters, and according to this, it only went 14.11 meters in terms of vertical displacement, but there's also something else that we have to consider. It said in the question that the arrow was shot from eye level, and eye level was defined in the question to be 1.7 meters. So if we add the 1.7 meters on to the vertical displacement, we get 15.81 meters, which is greater than 15. So that means that the wall is cleared, and yeah, he isn't executed, which was the question itself. So now the second question here is, does he actually win? So the thing is, at the beginning of the question, it says that he has 141 points in this tournament, and that his opponent has 151, and that if somebody hits the center of the target, the middle 4 meters of the target, they get 50 points. If they hit any other part of the target, they get 10 points, and if they don't hit the target, they only get 1 point. So basically, to win, he needs to hit the center part. If he hits any other part of the target, he'll draw, and if he doesn't hit the target, he will lose. So that's where that is what we are trying to find out now. So to do that, the first thing that we have to do is calculate the total amount of time it takes for the arrow to reach the ground after being released at an angle of 60 degrees, just as the archer did. So we're going to use the same equation this time. We're going to use the same formula. We know 3 of these variables, and we're trying to find out the 4th, but this time it's time that we're trying to find out. We know a vertical displacement because obviously the arrow has to travel 151.7 meters below its starting altitude, according to the diagram, and then initial velocity is again what we calculated at the beginning, and acceleration is always negative 9.8 according to gravity on Earth. So after we solve for that, it turns into a kind of a quadratic equation, but because of the way that it works out, the two answers, the two possibilities for t are but by the time you get the 2 possibilities for t, it's pretty obvious which one it has to be, because t has to be positive since it's a time value, and one of the values that it's giving is negative, so we can automatically eliminate that one. And as you can see here, that's what I did. Since t is greater than 0, it could only have been this solution here, so it works out to be 5.75 seconds in terms of the total time it takes for the arrow to reach the ground. So now what we do next is find the range. We have to find the horizontal displacement for the arrow if it travels 5.75 seconds, because remember, now we know that it can clear the wall. There's nothing else for us for the arrow to clear anymore. We know that it's going to clear the wall. We just have to find out how far it goes in 5.75 seconds now. And the way we do that is we use, again, this this fundamental formula: displacement equals velocity times time. We know what velocity and time are now. So velocity is the horizontal component of the velocity that we worked out at the beginning, 12.45 meters per second. And the reason for that is because there's no horizontal acceleration especially since I specifically stated in the question that there was no air resistance. And then time is 5.75 seconds according to this that we worked out right here just now. And if we multiply them together, we get 71.55 meters. So now the question is, how do we use this to work out whether the archer won the tournament or not? So if we go back to this diagram, we can see that the archer is standing here 10 meters away from the wall, and the center of the target is 60 meters away from the wall. So that means if the arrow displaces 71.55 meters from its initial starting position, it would travel to the center and 1.55 meters past it. Because the center portion of the target is 4 meters across in both it is 4 meters wide. That means that it goes 2 meters in either direction. 71.55 meters means that the arrow went 1.55 meters over the center of the target, which is less than 2. And that means that it managed to hit the center portion of the target. And because of that, we can see that he wins because he hits the center portion of the target, gets 50 points. Now he has 191, and he ends up beating his opponent. So now on to the final question. This is a sound question. How long after shooting the arrow does he hear the crowd's reaction if they react 0.3 seconds after the impact of the arrow? So the first thing that we have to do for this question is use the speed of sound formula that we learned for the sound unit. So it's basically this: velocity of sound equals 332 meters per second plus 0.59 multiplied by t, where t is the temperature. And if you look at the first sentence of this question, it says that the temperature is 20 degrees Celsius, and we can use that to substitute back into the speed of sound speed of sound formula, and work out what the speed of sound is for this question. So substituting 20 in, we get 343.8 meters per second, and now we can use this to work out for time if we know what the displacement is as well, obviously. And we can find out displacement because it says what it is in the penultimate sentence of the question itself. As you can see near the bottom, it's the final line. The final line of the question says that the crowd is 40 meters away from him, and if the speed of sound is 343.8 meters per second, and they're sitting 40 meters away from him, we now have enough information to work out how long it took for the sound to travel from the crowd to the archer. And once again, we use this formula here. Time equals displacement divided by velocity. So if we substitute 40 in for the displacement, since the crowd was sitting 40 meters away, and 343.8 in for velocity, since that was the speed of sound we calculated, we get 0.12 seconds. So it takes 0.12 seconds for the sound to travel from the crowd to the archer. But that's not the answer to the question. If we look at the question again, we can see that it actually asks how long after shooting the arrow does he hear the crowd's reaction if they react 0.3 seconds after the impact of the arrow. So to take all of this into account, we have to find out how long it takes. We have to take into account how long it takes to for the arrow to go from being released to hitting the ground, and then add an additional 0.3 seconds on top of that, since that's just the crowd's delayed reaction. And as you can see here, that's what I did. 5.75 seconds was the amount of time that we worked out before it would take for the arrow to hit the ground. Then 0.12 seconds here is what we just worked out for how long it takes for the sound to go from the crowd to the archer, and then the 0.3 seconds is the additional delayed reaction. So therefore he hears the crowd after 6.17 seconds. Alright, so that's all. I hope that made a lot of sense. These are just the basic answers for each one of the questions. A was just if he no, A just asked if the archer would be executed. The answer to that is no. B just asked if he would win. The answer to that is yes. And C just asked how long it would take for him, how long after shooting the arrow he would hear the sound of the crowd, and the answer to that is 6.17 seconds. So yeah, these are the very basic answers. I hope this explanation made a lot of sense, and yeah, good luck on the exam.